Let us now discuss about decision theory. Most complex executive decisions are decisions that must be made in an environment of uncertainty. Often, the manager must choose among several different courses of action in an attempt to optimize his decision process. Decision theory helps the decision maker address the problem of making complex choices under uncertain conditions. However, decision theory does not generate alternative courses of action. It merely provides a rational way of choosing among several alternative strategies. That means the alternative strategies would still have to come from the user. And then, once he has formulated his alternative strategies, then he would just make use of decision theory as a way to analyze the alternatives he has come up with. This means if the strategies that he has formulated in the first place are incorrect or not sound, then even though he applied decision theory correctly, the final output would still be incorrect. It's a form of garbage in, garbage out. So this particular technique is just a way to analyze alternative courses of action. Much of the utility of decision theory is that it forces a systematic and rational structuring of the pertinent information for making a given decision. Following are some applications of decision theory. First is natural resources development. It can answer questions such as, should an oil or gas well be drilled? What set of seismic experiments should be run? What is the expected payoff of the investment in exploration? For agricultural applications, it can also answer questions such as, what crops should be planted? Should excess acreage be planted? What actions should be taken to fight pests? For financial applications, what is the proper investment portfolio? What capital investment should be made this year? Marketing. It can also answer questions such as which new product should be introduced, what is the best distribution channel to use, what is the best inventory strategy. Production applications. Which of several different types of machines should be purchased? What maintenance schedules should be used? And it can also be applied for personal decisions to answer questions such as what college should you go to, what should you major in, should you go to graduate school or to work after graduation, and if to work, which job offer should you accept? It can even answer the question, should you get married or not? So this is the mathematical way of determining decisions that before might have been based solely on gut feel or on matters of the heart. So this is what you can use to balance your gut feel and your heart decisions for decisions concerning your future. Let's look at a scenario. Imagine yourself as the president of a small manufacturing firm. One of your bright young engineers has developed a new household gadget for testing hot dogs or for roasting hot dogs and has obtained a patent on the device. Since she developed the hot dog roaster on her own time, she is offering to sell the patent rights for 500,000 pesos or 250,000 pesos plus a 2% royalty on total revenue. From your experience, you surmise that demand for the roaster will be one of three levels. 1. The roaster will find no acceptance by the consuming public, in which case your total investment in the patent will be lost, as will the 1 million pesos needed to develop and promote the product. The second demand level possible is one of 20,000 units. The selling price of the roaster is expected to be 200 pesos, and the variable cost, not including patent cost and developmental cost, is estimated to be approximately 120 pesos. The third level of demand is estimated to be 100,000 units. Based on the given data, what is your decision? So for this scenario, we are going to apply the decision theory approach. What are the steps involved? Step 1. Identify the alternative decisions that can be made. So in the example, there are three conceivable decisions that the decision maker can choose from. Let the variable d sub 1 represent the decision to buy the patent rights outright for 500,000 pesos. Let the variable d sub 2 represent the decision to buy the patent rights for 250,000 pesos and agree to pay a 2% royalty on total revenue. And let the variable d sub 3 represent the decision to refuse to get involved in the hot dog roaster product. That is the first step. Identify the alternative decisions that can be made. Step 2. Define the various events or states of nature that affect the quality of the decision. What do we mean by states of nature? States of nature refer to what can possibly happen in the future that can affect your decision today. So you have to think of the possibilities that can happen in the future. So in our example, the states of nature correspond to the different levels of demand. Let the variable s sub 1 represent the possibility that there is no demand for the hot dog roaster. Let the variable s sub 2 represent the possibility that the demand would only reach 20,000 units. And let the variable s sub 3 represent the possibility that the demand would reach 100,000 units. So once you have identified the different alternative decisions that you can make, as well as the different events or states of nature that can affect the quality of your decision, step 3 would be for us to construct a payoff table or payoff matrix that depicts the payoffs given the different decisions that can be made and the different states of nature. This particular step suggests that we again have to have a tableau. This is your payoff table for the hot dog roaster. The labels for the rows would be your alternative decisions. The labels for the columns would be your states of nature. So once you have set up the tableau, all you have to do is to fill up the body of the tableau. Let's begin. If your decision is to pay 500,000 pesos outright for patent cost, which is represented by our D sub 1, and in the future there will be no demand as represented by S sub 1, how much would you lose? So definitely you are going to lose the 500,000 pesos that you have paid upfront for the patent cost. Additionally, if you refer back to the scenario, second sentence and the second paragraph says that you are also going to lose 1 million pesos which you need to develop and promote the product. Meaning, even though there is no demand, you are still going to spend for marketing collaterals perhaps or campaigns that would enable you to communicate to your target market the availability of your product, and that costs you 1 million pesos. So that means aside from the 500,000 pesos that you're going to lose that you paid out for patent cost, you're also going to lose 1 million pesos, which you are going to spend for marketing, campaigns, and other requirements to develop and promote the product. So in effect, you're going to lose a total of 1.5 million pesos. Okay. At this stage, what we are concerned with would be actual loss or gain based on the given data. We are not yet considering at this stage opportunity losses. You can complete this tableau either on a per decision or per row basis, or on a per column or per state of nature basis. My preference for this presentation would be on a per row or per decision basis. So I'll continue with this sub 1, which represents the decision to pay 500,000 pesos outright for patent cost. This time, let us test what if the demand would reach 20,000 units as represented by our S sub 2. So that means you now have to multiply 200, which is the selling price, multiply by 20,000, which is our assumed number of units to be sold. That would give us our total revenue. This particular tableau will therefore be filled up based on revenue minus cost. So you begin with your 200 pesos multiplied by 20,000, which would give us revenue minus the cost, beginning with your 500,000 pesos in terms of your patent cost. And then you also have to subtract 1 million pesos, which is your developmental cost. And then you also have there the variable cost given at 120 pesos per unit. So you have 120 multiplied by 20,000 units. And the product would again be subtracted from your revenue. If you do that, then you are going to get a total income of that much. So again, the payoff formula used for this example is payoff is equal to revenue minus patent cost minus royalty minus variable cost minus developmental cost. If we continue using that particular formula, let us now fill in the last cell in the first decision row. So again, our decision is to pay 500,000 pesos for patent cost. This time, let's assume that the demand would reach 100,000 units as represented by our S of 3. So again, in terms of revenue, that would be 200 pesos, which is the selling price, multiplied by 100,000 units this time, minus 500,000 pesos, which is the patent cost, minus 1 million, which is developmental cost, minus 120 multiplied by 100,000, which is now your variable cost. And that would yield 6.5 million pesos. We continue filling up the tableau. This time, we move on to the possible decision of paying 250,000 pesos in terms of patent cost outright, but at the same time, agreeing to pay 2% royalty on total revenue as represented by our D sub 2. If that is the case, and then we are going to test what if there is no demand in the future, then you're going to lose your 250,000 pesos cash out for patent cost plus your 1 million pesos developmental cost, or you're going to lose a total of 1.25 million. And then if the demand would reach 20,000 units, then you again have 200 multiplied by 20,000, which is your revenue, minus 250,000 pesos, which is your patent cost, minus 0.02, representing 2%, multiplied by, you have 200 multiplied by 20,000, which is your total revenue. So 2% of total revenue, that is your royalty this time, minus 120 multiplied by 20,000, which is your variable cost, minus 1 million, which is your developmental cost. And that would yield a total of 270,000. And then if the demand would reach 100,000 units as represented by S of 3, again following the payoff formula shown on the screen, then you are bound to get 6.35 million. And then if you decide not to invest as represented by our D sub 3, you really don't care what would happen about the future. So that means in all the cells in that particular row, you are all going to get values of 0. This completes our tableau. So, based on what you see in this tableau, what would be your decision? If you would realize the process, it is a very systematic way of analyzing all your possible decisions given your assumptions of what would happen in the future. It puts everything in just one table so that you can have a bird's eye view of the possibilities that can happen, both the negative and the positive side. So again, looking at your tableau, what would be your decision? In this case, there is really no singular best decision because the decision is actually based on the personality of the decision maker. Some decision makers are risk averse or they shy away from risk. Some are risk takers or they love risks because they know that the higher the risk, the higher the return. And yet, other individuals also have the stance of simply waiting for what others would do or what their competitors would decide on, and then simply copying what they did if such decision worked for them. So again, it depends on the personality of the decision maker. Still, perhaps we can do some systematic way of singling out which decision would be best for you. So I now have here the following criteria for decision making when state of nature probabilities are unknown. When we say state of nature probabilities are unknown, that means in our examples, you do not know exactly what is the probability that there will be no demand in the future. Nor do you know the probability that the demand would only reach 20,000 units, nor do you know that the probability of having 100,000 units being sold in the future. All you know is that those three events are possible, but as to the exact probabilities of each of those events, then you are not aware or you are not sure. If that is the case, then following are the criteria that you can use to determine which is the best decision for you. Again, this would be based on your personality. First is what is known as the max-min criterion. This criterion simply maximizes the minimum payoffs given the various decisions that are possible. So once the payoff table has been formulated, the first step would be to identify the minimum payoff for each decision. The next step would be to pick the largest minimum payoff. That's why it's called maxi-min. This rule is a very conservative one that takes a pessimistic view of the various states of nature. So this is for the risk-averse personality, or for those individuals who have very limited capital and they would like to make sure that they are going to invest their capital to something that would really provide them with the revenue that they are targeting. Let's apply. Going back to our tableau, let us now analyze it one decision row at a time. Let's begin with decision number 1. For the decision number 1 row, the minimum value you can find there is your negative 1.5. For decision number 2 row, the minimum value you can find there is negative 1.25. And for decision number 3 row, well, whatever value you find there, the minimum is 0. Now that you have identified the minimum values per decision row, the next step would be to identify the largest value among the minimum values you have identified. In this case, the largest value there is 0, representing your D sub 3. So under maxi-min, your decision would be not to invest. Again, this is a criterion used by the pessimist or the risk-averse individual. Sometimes, though, you would not have a decision number 3 row wherein all the values are zeros. Sometimes there is a need for you to make a decision. Okay? For example, if you are in a corporation that suddenly has a liquidity level of around 5 billion pesos, that is too high already. You have to make a decision. Perhaps you are waiting because the interest rates are still increasing and you don't want to lock yourself to a particular interest rate. That's why you continue waiting until the market stabilizes. But at 5 billion pesos in liquidity, you are losing out already on that particular opportunity. So sometimes you have to just bite the bullet and invest, even though on hindsight you know that it is possible that you can get more if you could have waited. But still, there is also the possibility that the interest rates would suddenly go down and then you would have lost the opportunity of investing at a relatively higher interest rate. Another criterion that you can use is the maxi-max criterion. So initially we have maxi-min, we are now at maxi-max. Before you get any crazy ideas, I am now going to inform you that there is no mini-min. So let's now go to maxi-max. This criterion maximizes the maximum payoffs for the different decisions. One begins by identifying the maximum payoffs for each alternative decision, and the final decision is that which yields the largest maximum payoff. So as opposed to maxi-min, this now is an extremely optimistic criterion for choosing alternative decisions. This is usually used by investors who are risk takers, they are venture capitalists, or those who have a lot of money to play with. Let's apply the concept to our tableau. Again, on a per decision row, let us first apply the maxi-max. Okay. For decision number 1 row, the maximum value you can find there is your 6.35 million. For decision number 2 row, the maximum value you can find there is your 6.35. The first one is 6.5. Okay. And then decision number 3, whatever value you find there is 0. Apologies, but I did not use my glasses for this video. So among the maximum values we found per decision, the maximum is the one found at decision number 1, which is your 6.5. So under maxi-max, you have to decide to pay 500,000 pesos outright for your patent cost. So we have maxi-min, we have maxi-max, and we said there is no mini-min. So what is left is mini-max. But this time it is in the form of a regret. So we have now the mini-max regret criterion. This is now where we take into consideration opportunity losses. So this criterion involves the construction of an opportunity loss or regret matrix prior to applying the minimax rule. To construct an opportunity loss table, each element in the payoff table has to be transformed into an opportunity loss. The magnitude of the opportunity loss for a given element is the loss incurred by not selecting the optimal alternative decision given a particular state of nature. Meaning, what would happen if I do not choose the best decision given a particular state of nature? If I chose an inferior decision for a particular state of nature, then what would be my opportunity loss in doing so? That is the concept behind the minimax regret criterion. So, to convert a payoff table to an opportunity loss table, the first step is to find the largest element in the first state of nature column. This element represents the best decision given a particular state of nature. This means we now shift our attention from a per decision row basis. This time we are going to begin with a per state of nature or per column basis. Looking back at our tableau, let's begin with the S sub 1 state of nature column. The largest element we can find in that column is 0, represented by your D sub 3. Meaning, if ever in the future there is no demand, your best decision today should have been not to invest. Next state of nature column, S sub 2. Looking at the values in that column, the largest element we can find there is your 270,000. Meaning, if in the future the demand would reach 20,000 units, then your best decision now should have been to pay 250,000 pesos and agree to pay a 2% royalty on total revenue as represented by our D sub 2. And then, for the S sub 3 state of nature column, the largest element we can find there is our 6.5 million, which represents D sub 1, or to pay 500,000 pesos outright for patent cost. That would be the best decision if in the future the demand would reach 100,000 units. So this is the first step. identify the largest element per state of nature column. The second step is to subtract each element in the column from the largest element to compute the opportunity loss. Then repeat the process for all columns. Let's apply the concept. So, the largest element we found in the S sub 1 state of nature column was 0. If you now subtract each element in that column from 0, then you have 0 minus negative 1.5 is positive 1.5. That is the amount that you would have lost if you have decided to pay 500,000 pesos outright for patent cost, and yet the demand is not there, because you should have decided not to invest in that instance. Repeating the process, 0 minus negative 1.25 million is positive 1.25 million, and then 0 minus 0 is 0. For the S sub 2 state of nature column, the largest element we found earlier was 270,000. So 270,000 minus 100,000 gives us 170,000. 270,000 minus 270,000 is 0, and then 270,000 minus 0 is 270,000. For the third state of nature column, the largest element we found was 6.5 million. So 6.5 minus 6.5 is 0. 6.5 minus 6.35 million is 150,000. And then 6.5 minus 0 is 6.5. That is how to construct an opportunity loss table. And then, the minimax regret criterion involves the identification of the maximum regret or opportunity loss for each decision, and then choosing that decision with the smallest maximum regret. Let's apply this criterion. So once you have created your opportunity loss table, you again shift your focus to a per decision row basis. Let's begin with decision number 1 row. What is the maximum value you can find there? It is your 1.5 million. That is the maximum opportunity loss for decision number 1. For decision number 2 row, the maximum value we can find there is 1.25 million. Again, that is the maximum opportunity loss for decision number 2. And then for decision number 3 row, the maximum value you can find there is 6.5 million. Among the 3 maximum values we identified per decision, which now is the minimum? Among the 3, the minimum is your 1.25 million, which represents decision number 2. Therefore, under minimax regret criterion, your decision would be to pay only 250,000 pesos for patent cost, but agree to pay a 2% royalty on total revenue. This particular criterion for decision making is not optimistic, it's not also pessimistic, but it gives a decision from a different perspective, which is from the opportunity loss perspective. What if state of nature probabilities are known? If the probabilities of the states of nature can be estimated, the expected values of various decisions can be calculated. Let's have a different example. There are 100 opaque urns, each filled with 10 balls. There are 2 different kinds of urn. Type 1 urn holds 5 black balls and 5 white balls. Type 2 urn has 8 black balls and 2 white balls. There are 70 type 1 urns and 30 type 2 urns. An urn is picked at random from the 100 urns, and you are asked to guess whether it is type 1 or type 2. If you guess that it is a type 1 urn, and it is, then you win 500 pesos. But if it is a type 2 urn, you lose 200 pesos. Now, if you guess that it is a type 2 urn, and it is, you win 1,000 pesos. But if it is a type 1 urn, then you lose 150 pesos. Remember that you as the decision maker has 2 types of urns to choose from. In other words, there are two states of nature, S sub 1 and S sub 2, corresponding to the urns of type 1 and type 2. You have three alternatives. You can guess either type 1 or type 2, or refuse to take the gamble. So, based on the scenario, which action would you take? Again, let's solve this type of scenario by having a tableau. So, your alternative decisions are D sub 1 represents your decision that every time you're asked to guess, your guess is type 1. D sub 2 is your decision that every time you're asked to guess, your guess is type 2. And D sub 3 is your decision not to play the game. Whereas S sub 1 is a state of nature that the urn that was picked for you to guess is a type 1 urn. While S sub 2 is a state of nature whereby the urn that was picked for you to guess is a type 2 urn. So let's fill in now the body of this tableau. If your decision is to guess type 1 and the urn presented to you is a type 1, then based on the data, you are going to earn 500 pesos. However, if your guess is type 1 but the urn presented to you is a type 2, then you lose 200 pesos. Now, if your guess is type 2 but the urn presented to you is a type 1, then you lose 150 pesos. And then if your guess is type 2 and the urn presented to you is a type 2, then you earn 1,000 pesos. Now, if your decision is not to play the game, you really do not care what urn is presented to you. So you have values of zeros there in that row. Now, what is different in this scenario over the previous example we had was the fact that you have an idea of what is the probability of each state of nature from happening. That is based on the last sentence of the first paragraph, which says, there are 70 type 1 urns and 30 type 2 urns. So conveniently, that implies that there is a 70% chance that the urn that would be picked for you to guess is a type 1 urn. And there is a 30% chance that the urn that would be picked for you to guess is a type 2 urn. That means the probability of state of nature number 1 is 70% or 0.7, while the probability of state of nature number 2 is 30% or 0.3. So in our tableau, we have to add those probabilities of our states of nature. So we have 0.7 for S sub 1 and 0.3 for S sub 2. Considering that the state of nature probabilities are known, then the expected monetary value of each of the three alternative actions can be determined using the following basic formula. Expected monetary value of a decision is equal to the summation from I equal to 1 to capital letter N of P of S sub I multiplied by X sub I, where capital letter N represents the number of states of nature, P of S sub I is the probability that the true state of nature is S sub I, and X sub I is the payoff for the alternative action given S sub I is the true state of nature. Let's apply this formula to our tableau. So we are now supposed to determine the expected monetary value for each decision. For decision number 1, applying the formula, that would simply be equal to 500 multiplied by 0.7 plus negative 200 multiplied by 0.3. The sum would be the expected monetary value, which is 290 pesos. For decision number 2, again applying the expected monetary value formula, you have negative 150 multiplied by 0.7 plus 1,000 multiplied by 0.3. The sum would give us 195 pesos. And for decision number 3, 0 multiplied by whatever value is 0, and then adding zeros would also give you a value of 0. So once you have computed for the expected monetary value of each decision, then simply pick the decision that gives you the highest expected monetary value. In this case, that is your decision number 1 with an expected monetary value of 290 pesos. So what does that 290 peso value mean? It means as the number of opportunities for you to guess increases, and that every time you are asked to guess, your guess is consistently type 1, represented by your D sub 1 decision, then on the average, you are going to earn around 290 pesos. Whereas, as the number of decision opportunities increases and your decision is always D sub 2 or type 2, you are merely going to earn an average of 195 pesos. Therefore, you are better off guessing type 1 or decision number 1 every time you're asked to guess. So this particular approach is very straightforward since it makes use of a formula. It does not depend on your personality, whether you are risk averse, a risk taker, or someone who looks at opportunity losses. So how would you apply this approach to our earlier example wherein we do not know the probability of each state of nature? Let's go back. So in this tableau, we do not know the probability of each state of nature. But if you would like to apply the straightforward approach of computing the expected monetary value of each decision, all you have to do is to assume equal probabilities to each state of nature. In this case, you have 3 states of nature. So since the perfect probability is 100%, then you assume that each state of nature has a probability of 33.33%. Or you give them an equal probability of happening. Unless, of course, in some instances, you might give a higher probability to a particular state of nature based on your past experience. That is also okay, so long as the sum of the probabilities that you have assigned to all your states of nature would be equal to 100%. Then you have a visual way of determining how you came up with your final decision, and that is the use of a decision tree. A decision tree is a way to visualize a typical decision theory problem. There are 4 didactic or instructive parts to a decision tree. Namely, you have decision nodes represented as squares. These represent the choice among alternatives. Then you have alternative branches, which are straight lines that represent alternatives. So, coming from the decision node, these branches show or name the choices. You also have chance nodes, which are represented as circles. So coming from the branches, these nodes represent factors in the decision situation over which the decision maker has no control. And then you have probabilistic branches, which are straight lines that represent probabilities. So from the chance nodes, these branches represent the actual or estimated numerical likelihood of various chances. To evaluate a decision tree, it is necessary to evaluate each chance node and each decision node. Chance nodes are evaluated using the expected value, and the value of a decision node is the expected value of the most desirable alternative action. Using our earlier example of the choice of earn, if we are to represent that as a decision tree, we begin with a decision node, which is a square. And then you have the alternative decisions, which are your alternative branches. D sub 1 representing your decision that every time you're asked to guess, your guess is type 1. D sub 2 is your decision that every time you're asked to guess, your guess is type 2. And D sub 3 representing your decision not to play the game. Then you have your chance nodes. Now, for each of the decisions, there are 2 states of nature. Either the earn that would be presented to you is a type 1 earn or a type 2 earn. And then we also have the probabilities. Since there are 70 type 1 earns, then the probability of a type 1 earn being presented to you is 70%, while since there are 30 type 2 earns, then the probability of a type 2 earn being presented to you is 30%. So those are your probabilistic branches. So based on our analysis earlier, if your guess is type 1 and the earn presented to you is a type 1, then you earn 500 pesos. However, if your guess is type 1, but the earn presented to you is a type 2, then you lose 200 pesos. Now, if your guess is type 2 and the earn presented to you is a type 1, then you now lose 150 pesos. But if your guess is type 2 and the earn presented to you actually is a type 2, then you earn 1,000 pesos. And if you decide not to play the game, then whichever earn is presented to you, you have values of 0. And then, in terms of the expected monetary value computation, for the first probabilistic branch, under decision number 1, you have 500 multiplied by 0.7, and then plus negative 200 multiplied by 0.3, which gave us an expected monetary value equal to 290, which we are going to place in the first chance node. Then for the second chance node, you have negative 150 multiplied by 0.7 plus 1000 multiplied by 0.3. That gave us a value of 195 earlier, which we're going to place in the second chance node. And then for the third chance node, that would be 0 multiplied by 0.7 plus 0 multiplied by 0.3, which would give us a value of 0. And then among the 3 expected monetary values in each of our chance nodes in this decision tree, the highest is your 290, which is connected to your D1 or decision number 1. Therefore, in the decision node, that is now where you're going to place D sub 1. This is your decision tree construction, which is a visual way of determining how you came up with your final decision. The decision node branch depends on the number of decisions that you have to make, meaning it is possible for you to have more than one decision node in your decision tree. For example, after graduation, you might decide whether to stay in the Philippines or to go abroad. So that is one decision in itself. After which, if let's say you are already in the place where you prefer to work, then the next decision would be what type of work are you going to accept? Would it be a table or a clerical type of work, or an entrepreneur type of work wherein you have to start your own business? Then that is again another decision point, and therefore would be represented by another decision node. So again, the number of decision nodes depend on the number of decision points that you have to make. This is your decision theory.